Alright, so I decided to go through and do the free response questions in your chapters 5 and 6 tests, and then the multiple choice answers. I scanned the document, but I guess it didn't scan properly, and I didn't check it before I left work, so I will not be able to post the multiple choice answers. But what I will do is give that out in class on Monday, and then if you have any questions, you guys can come and see me during lunch on Monday. So let's start off with, I'm actually going to go backwards. I'm going to do the Chapter 6 free response question first, because there's only one of them. And then I may just do another video for the Chapter 5, because it'll be pretty long. So starting off, the first question that you got was, given the differential, create the slope field. So I'm actually not going to go through and do all of them. I want to mention a few important ones. So when I'm creating the slope field, the slopes you actually find by doing the dy dx equation. So dy dx, that is the slope of every single tangent line in the whole entire graph. This graph, they only gave you 12 points to find them for. The equation is for y minus 1 over x squared. So given this point right here, 0, 0, then I would put in 0, 0. I won't do all of these, obviously. And I get 0 minus 1 over 0, which is undefined. So you actually don't draw anything there. You don't have to draw a vertical tangent. You just leave it blank. The next one that I could possibly draw, let's do 2, 1, which would be here, this point. And I do go in order, but I just wanted to show a few of them. So 2, 1, so 1 minus 1 over 2 squared, that is 0 over 4. So that's a 0 slope. So at that point, I would show a horizontal tangent. So in case you want to see what this answer looks like, I actually have it here. So, and I'll kind of access this each time. So you got 1 point for your 0 slopes, and then you got 1 point for all your other slopes. Alright, so next piece, this is the one that was worth the most. So this was to solve the differential equation with the initial condition. So obviously we need the initial condition. We're going to start over here, dy. I'm actually going to do the division right now, is equal to dx over x squared. And from there, and again, I'm really sorry about the feedback noise. It's that same computer that started doing crazy feedback at some point, and I can't fix it. Alright, so there we go. So the left side, I can tell that because this is a power of 1y on the bottom, that this is going to be an ln, but I can't just do the ln. I'm going to have to do a u substitution. So u is equal to y minus 1, du is equal to 1 times dy. So, oopsie. dy is equal to, it would be divided by 1, but dy is equal to du. So I can fix this integral to be in terms of u, and I end up having u over u. Alright, du over u. And the right side, I'll do it in pink, this could be rewritten as the integral of x to the negative 2 times dx, and so I get add 1 to the power, x to the negative 1, divide by that power. So we end up with that this would be the integration of the right side. So I'm going to finish up this one here. So the ln of u is equal to negative 1 over x and then plus c. So ln of u, I'm going to use that e to all of this. Next part, then I get this to cancel, and I get that the absolute value of u is equal to e to the negative 1 over x times e to the c. And at this point, I sometimes go back and forth with this. I actually like having my y's back in for these problems because this is not a substitution problem where I'm going to give a numeric answer. I'm going to have to get this back into y's, so I'm going to go and put the y's back in. That should be y minus 1. I'm going to rewrite this so that the constant is in front and then this is in the back. And then the absolute value, if I move that, I get plus or minus e to the c times e to the negative 1 over x. And so this I'm going to rewrite as a. So I get y is equal to a e to the negative 1 over x and then plus 1. So this would be my y. That's part of the answer. Now I got to go through and create the actual specific equation by using the point 2, 0, 2 being the x, 0 being the y. So y, 0, is equal to a e to the negative 1 over 2 plus 1. So let's see. So we're going to hope that I did all of this right and move this over. So I get negative 1 is equal to a e to the negative 1/2. Then I'm going to divide by e to the negative 1/2 equals a, and that just looks really odd because I have a negative exponent, so I'm going to make that a positive exponent, so this will move to the upstairs and become positive, so negative 1 times e to the positive 1/2 is equal to a. So a is just equal to negative e to the 1/2. Therefore, the actual equation is y is equal to negative e to the 1/2 times e to the negative 1 over x plus 1. Okay? The last piece asked for you to find all points in the xy plane such that dy dx is negative. So this was actually really disappointing to see because you would have had a lot of practice on that type of question. And the worst thing, and when I taught it, I said the worst possible thing that you could do is to list the points that you got in part A and list all your negatives. So if you sat there and you listed your negatives, then it means you didn't understand the question, nor did you go through and properly do the free response practice problems. Find all points in the xy plane. There are an infinite amount of points, not 12. So you have to give all of them, and we practice this in the notes, we practice it in homework, and we practice it on free response questions. So how can I make dy dx negative? So you take dy dx, which is equal to y minus 1 x squared. So when you see something like negative, it means you're really looking at it, in a sense, a sign chart. So I'm trying to make this to be less than 0. So I'm going to just start out with, how would I make this equal to 0? And the other one I want to look at is, how would I make this undefined, because this is how we do a sign chart, right? So this would be equal to 0 if y is equal to 1. This would be undefined if x equals 0. Given that y is equal to 1, if I look at the fraction, what I will notice is this piece of the derivative is always going to be positive, so the only way that I could create a negative is if y minus 1 is negative. So y minus 1 is negative when, if I was to do a sign chart for y minus 1, 1 would be here. If I put 1 into this, I get 0. If I put negative 1 million into this, it's negative, and if I put positive 1 million into this, I get positive, and into this I meant y minus 1. So it is negative when y is less than 1, and you could reason that out and not do a sign chart, but you needed to understand that you needed this piece that was part of it, and then I also needed you to realize x better not be 0. So that was the other piece I was looking for. Okay? And that was 1 point. Alright, so that was Chapter 6 free response. I'm going to stop the video there and do a different one for Chapter 5.